And in this lecture, we're going to talk about verifying or proving trigonometric identities. So before we get started, let's revisit some of the basic identities we've already learned. First, we have the reciprocal identities. Cosecant of theta equals 1 over sine theta, secant of theta equals 1 over cosine theta, and cotangent theta equals 1 over tan theta. We also have the quotient identities. Tangent of theta equals sine of theta over cosine theta, and cotangent of theta equals cosine theta over sine theta. And finally, we have the Pythagorean identities. Sine squared theta plus cosine squared theta equals 1, tan squared theta plus 1 equals secant squared theta, and 1 plus cotan squared theta equals cosecant squared theta. So using those basic trig identities, we can use the following guidelines to establish other trig identities. The first thing that we want to do if we're trying to prove a trig identity is to start with the side of the equation that is more complicated. Another helpful hint is to rewrite the sums or differences of quotients as a single quotient. It's often beneficial to rewrite things in terms of sine and cosine. And as you're working through the problem, keep your goal in mind. So let's do some examples. The first thing we want to do is we want to show that the sine of theta times cotangent theta plus tangent theta equals secant theta. So we'll start with the more complicated looking side, that's the left-hand side. Sine of theta times cotangent theta plus tangent theta. We'll use the quotient identities to rewrite this. Sine of theta times cosine theta over sine theta plus sine theta over cosine theta. If we distribute the sine throughout the parentheses, we'll get cosine theta for our first term, and we'll get sine squared theta over cosine theta for our second term. In order to add these together, we need to have a common denominator. So we'll multiply the first term by cosine theta over cosine theta to give us cosine squared theta over cosine theta plus sine squared theta over cosine theta. When we add them together, we get cosine squared theta plus sine squared theta over cosine theta. And cosine squared plus sine squared is one of our Pythagorean identities, so we can rewrite that as 1. So we have 1 over cosine theta, which we can rewrite as secant theta using the reciprocal identity. And so we have proved that the sine of theta times cotangent theta plus tangent theta equals secant theta. Here's another example. We want to show that tangent squared theta times the cosine squared theta plus cotangent squared theta times sine squared theta equals 1. So we start with the more complicated side of our equation. Tan squared theta, cosine squared theta, plus cotangent squared theta, sine squared theta. We're going to use the quotient identities to rewrite tangent and cotangent, so we'll have sine squared over cosine squared theta times cosine squared theta, plus cosine squared theta over sine squared theta times sine squared theta. If we multiply things out, we'll see that the cosine squared thetas cancel out in the first term, and the sine squared thetas cancel out in the second term, leaving us with sine squared theta plus cosine squared theta. That's one of our Pythagorean identities, so we know that that is equal to 1. And so we verified that tangent squared theta, cosine squared theta, plus cotangent squared theta, sine squared theta is equal to 1. Here's another example. This time we want to verify that 1 minus sine squared theta over 1 minus cosine theta is equal to negative cosine theta. Again, we start with the more complicated side, so we have 1 minus sine squared theta over 1 minus cosine theta. In order to combine these terms, we need a common denominator, so we'll rewrite 1 as 1 minus cosine theta over 1 minus cosine theta. If we combine the fractions together, we'll get 1 minus cosine theta minus sine squared theta over 1 minus cosine theta. If we use a variation of the Pythagorean identity, sine squared plus cosine squared equals 1, we can rewrite sine squared as 1 minus cosine squared theta. So we'll have 1 minus cosine theta minus 1 minus cosine squared theta over 1 minus cosine theta. We can simplify by distributing the negative sign, giving us 1 minus cosine theta minus 1 plus cosine squared theta all over 1 minus cosine theta. The 1 and the minus 1 will cancel each other out, leaving us with negative cosine theta plus cosine squared theta over 1 minus cosine theta. We could factor out a negative cosine theta from the numerator, giving us negative cosine theta times 1 minus cosine theta over 1 minus cosine theta. And the 1 minus cosine thetas in the numerator and denominator will cancel each other out, leaving us with negative cosine theta. So we've verified this identity, 1 minus sine squared theta over 1 minus cosine theta equals a negative cosine theta. Okay, we want to do tangent of theta plus cotangent theta equals secant theta times cosecant theta. So we'll start with the left-hand side, tangent of theta plus cotangent theta. Using the quotient identities, we can rewrite that as sine of theta over cosine theta plus the cosine of theta over sine of theta. In order to add these terms together, we need a common denominator, so we'll multiply the first term by sine of theta over sine of theta, giving us sine squared theta over cosine theta sine theta. And we'll multiply the second term by cosine of theta over cosine of theta, giving us cosine squared theta over cosine theta sine theta. Now that we have a common denominator, we can add our fractions together, giving us sine squared theta plus cosine squared theta over cosine theta sine theta. The Pythagorean identity tells us that sine squared of theta plus cosine squared of theta is equal to 1, so we have 1 over cosine theta sine theta. Using the properties of multiplication and division, we can split that up to be 1 over cosine theta times 1 over sine theta. And if we rewrite that using the reciprocal identity, we know 1 over cosine is secant, and 1 over sine is cosecant, so we get secant theta cosecant theta. And so we've proved that tangent of theta plus cotangent theta equals secant theta cosecant theta. Alright, final example. This time we want to show that sine of theta plus cosine of theta over sine theta minus cosine of theta minus sine theta all over cosine theta equals the secant of theta times the cosecant of theta. So we'll start with the left-hand side of the equation. In order to combine these two terms, we need to have a common denominator, so we'll multiply the first term by cosine of theta over cosine of theta, giving us sine theta cosine theta plus cosine squared theta all over sine theta cosine theta. And we'll multiply the second term by sine theta over sine theta. So we'll have sine theta cosine theta minus sine squared theta all over sine theta cosine theta. Now that we have a common denominator, we can put this all together in one fraction, so that'll be sine theta cosine theta plus cosine squared theta minus sine theta cosine theta minus sine squared theta all over sine theta cosine theta. If we distribute the negative sign through the second term in the numerator, we'll get sine theta cosine theta plus cosine squared theta minus sine theta cosine theta plus sine squared theta all over sine theta cosine theta. The positive sine theta cosine theta and the negative sine theta cosine theta in our numerator will cancel each other out, leaving us with cosine squared theta plus sine squared theta over sine theta cosine theta. We can use the Pythagorean identity in our numerator and rewrite cosine squared plus sine squared as 1, so we have 1 over sine theta cosine theta. And just like in the previous example, we can split that up to be 1 over sine times 1 over cosine, which using the reciprocal properties will be cosecant theta times secant theta. And so we've proved the identity sine theta plus cosine theta over sine theta minus cosine theta minus sine theta over cosine theta equals secant theta times cosecant theta.